Let's take a look at equations that can be written as quadratics. At first glance, this particular equation doesn't look like a quadratic equation, but we do have a variable in the denominator, and to solve for x, we're going to have to get rid of that denominator. My recommendation is that you multiply through by x. So that means we take the first term, multiply it by x, take the second term, multiply it by x, and then don't forget the other side, multiply it by x. When we do this, the first term becomes x squared. The second term, those x's divide out to give you 12. And on the other side, we get 7x. Subtract 7x from both sides because we need it equal to 0, remember, to use the 0 property, giving us this. Now, here's our quadratic. So we can go ahead and use one of our quadratic equation solving methods. For this one, it is factorable. Because the 12 is positive, it says both factors have the same sign. Because the first sign for the 7 is negative, they're both going to be negative. So we're looking at two factors of 12 who add to 7. Those two factors are 3 and 4. Then by the 0 property, we can take each factor and set it equal to 0. So we get 3, x and x equals 4. Depends on who you're working with. Some folks allow you to just go ahead and write what you have. Others make you show the 0 property, so be aware of what it is you're being required to do. So this guy has two different solutions. Let's go ahead and look at another one. This one's a little more complicated, and it's a little more complicated because the denominators are different. And so what we want to do is multiply through by the LCD, and this LCD is x times x minus 2, everything from both of those denominators, because neither of them have repeated factors in them. So we're going to have to take the first term, multiply it by the LCD, take the second term, multiply it by the LCD, and then that right-hand side and multiply that by the LCD. Now when we do this, we get lots of dividing out. These x minus 2's divide out. In this term, the x's divide out. And so we get 3x times x plus 1 times x minus 2. And on the other side, 4x times x minus 2. Let's go ahead and distribute in 3x squared plus x minus 2 equals 4x squared minus 8x. Let's go ahead and subtract 3x squared, subtract x, and add 2 to both sides. When we do that, this left-hand side becomes 0, and the right-hand side, 4x squared minus 3x squared gives you x squared, minus 8x minus x is minus 9x, and then add a 2, there was no constant over here. So here's our very simplified quadratic. And when we look at this, it's not factorable because the leading term would give us an x and an x in each factor. Are there two factors of 2 who add to 9? The answer is no. And so we're going to need to use the quadratic formula where this leading coefficient is 1. So pull off the a, the leading coefficient is 1, b, coefficient of the linear term, minus 9, c, the constant, and then remember, inside the quadratic formula, b squared minus, 4ac, b squared, negative 9 squared, minus 4 times 1 times 2. When you simplify that, you get 73. So that gives us then, let me scoot up a little more, this gives us then x is equal to negative b, so minus a negative 9 is plus 9, plus or minus the square root of b squared minus 4ac, that's 73, all over 2 times a, 2 times 1 is 2. So this is our final solution. You know, when you have equations and you're going to simplify them, and they may look like quadratics, but that also means then you may end up with something really ugly that you're going to have to use the quadratic formula for, but that still works. Remember, this is two solutions, 9 plus root 73 over 2 and 9 minus root 73 over 2. So be prepared when you get to this quadratic level to use factoring, square root method, or the quadratic formula, whatever works for you. Watch your LCDs. When you multiply through to clear fractions, don't forget to multiply the other side. That's it. Hope you're having a great day.